Hello, everybody, and welcome to the Cosmos Show, a place to be if you're curious about the universe. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get some advice from a space doctor, learn what astronomers have to say about life, and find out what's going on above your head, all in the same place. You can join us live every other Tuesday at 6 p.m. Mountain Time on Twitch, YouTube, and now Facebook as well. You can chat your questions on Twitch and YouTube, and then you can also call in, and you can ask your questions live by using the number that's right on your screen. You should have a number there and the ID that you'll need to log in to the Zoom call to talk to us live. And we'd love to hear you, so feel free to make a comment, ask a question, whatever suits your fancy. In this week's show, we are going to talk with Taylor Hutchison, who is a PhD candidate and NSF fellow at Texas A&M University. She studies galaxies, the galaxies that are the most distant ever discovered. And she'll be on later to tell you all about them. But before she joins us, let's welcome our co-stars. First, Deputy Director of Education and Public Outreach at the Vera Rubin Observatory, it's Dr. Lauren Corlees.
Hey, Sam. Happy to be here.
Hey, Lauren. Great to have you. Next, medical doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everybody.
Hey, Danny. Next, PhD candidate in astrophysics from the University of Chicago and host of her own YouTube show, Nora's Guide to the Galaxy, it's Nora Bailey.
Hey, y'all.
Hey, Nora. And last, but certainly not least, postdoctoral scholar from the Simons Observatory, it's Dr. Nick Galitsky.
Hi, everybody.
Hey, Nick. All right, well, good to have the whole crew back together again. We missed you last time, Danny. So let's
Missed you guys.
Let's move on to astro advice. Today we have we've got the one up from last week, Gavin. See if we can get the new one up. The new one for today is from not quite an astronomer, but she certainly qualifies in a lot of people's eyes. The quote is from Nichelle Nichols. If you know that name, she was Lieutenant Uhura from the original Star Trek. And as Gavin gets that image up, I will read the quotation that we have for this evening. Science is not a boys' game. It's not a girls' game. It's everybody's game. It's about where we are and where we're going. Space travel benefits us here on Earth, and we ain't stopped yet. There's more exploration to come. And there she is. That's one of the pictures of her as the cast, the original Star Trek. She is still alive. She's 89 years old now. She's collaborated with NASA and worked as a consultant, and has still represented Star Trek in lots of ways. So definitely one of my favorite characters from the original cast. And I would love to hear what the co-stars have to say about this quotation this evening.
Yeah, I love this quote. And I think that she's great. It's fun to get a non-astronomer in our astro advice. It reminds me of, oh, I'm sorry, I don't remember her name. On last year, talking about space tourism and kind of the importance of space and how there's a PR game to be had, and just reading this quote, she says space travel benefits us here on Earth, and I think that's absolutely true. And it's a constant PR struggle to get people to understand that, you know, we're not just interested in things for their own sake, although many of us probably are interested in them for their own sake as well. But there's tons of benefits to it, and it really can benefit everybody. And so I think, yeah, it's really important to keep that in mind and to try and spread that word if we can. There's the, I don't know if y'all have seen any commercials lately, but there's been a couple, in particular, I'm thinking of the Salesforce one with Matthew McConaughey, that's like poking fun at the whole concept of space even being important. And it makes me really sad. And I feel like, yes, billionaires going to space doesn't really do anything for the rest of us, but that's like the tiniest portion of what space and space travel is. And so, yeah, I think it's important to know that there's still a lot ahead.
I am so glad you brought up that commercial about Salesforce, Nora. I was going to bring that up. I don't watch a lot of TV. I was actually at a friend's house this weekend. We were watching the Olympics, and that commercial came up. And we were both like, WTF? Like, why did Matthew McConaughey agree to do that? First of all, why did he agree to wear a spacesuit doing it? And like, what is Salesforce thinking? I don't know if the rest of you saw this commercial or not, but it's Matthew McConaughey like parading around. First he's in a hot air balloon, and then he's walking on a planet somewhere. I don't remember exactly, but he's like trying to draw everybody's attention that we need to focus on Earth and not like up in the heavens. And like what it has to do with Salesforce, I have absolutely no idea. Um, and yeah, I totally agree with Nora that yeah, I think it really does a disservice to those of us who are really interested in paying attention to everything above our heads. Yeah, I hope Salesforce takes a lot of flack for that because yeah, it was pretty disappointing for me as well. But to your point, your other point, Nora, which is probably the more important one, I completely agree that that space travel has huge benefits. And what always comes to mind first for me is Velcro, one of the very early inventions that came out of the space race. And I will defer to Danny on this one. I think she can probably tell us like 100 other things that have benefited humanity from human space life and space travel. So I'll mute myself again and let me and the rest of you comment.
Oh, you know, it's funny, Sam. So, first of all, I did see a photo from that, like a snapshot from that particular commercial that you're talking about with Matthew McConaughey. And then I read a little blurb, and that was enough for me to get the gist. And it was like, okay, you know, I think they're maybe they're missing the bigger picture, like the larger point. But it's interesting, just within the last couple of weeks, I gave a presentation at a conference that's NASA funded. It's called the Human Research Program Investigators Workshop. And it was on the value of the commercial space flight, like the near future, the next several years of commercial space flight from a human research perspective. Because the reality is that we know some things right now about the human body in space, but there's a lot to learn. And a lot of our, you know, as the other scientists on this call can appreciate, there's a lot to learn that we really just need to have the N number go up, you know, to be able to gather data on more people and on a wider swath of people. And so the fact that, you know, space travel absolutely it will benefit us on Earth because we'll have a better understanding of human physiology across the board, you know, not just in the spaceflight realm, but given the fact that space is actually an accelerator for aging in a lot of different circumstances for the human body. So the medical insights and the potential for for additional understanding and like tech advancements is truly limitless. So I'll stop there. I could talk for a long time about that, but but yeah.
I think we all get this question at some point of like, well, couldn't we spend this money on something else? To which I like to say, like, that's a false choice. That's a false dichotomy. It's like, yes, I want to spend money on this and that. Like, there's no reason why you have to choose one or the other. Like, everything is possible. And so let's not back ourselves into choices that we don't actually have to make. I agree. I think there's a lot of value to all of this, and just like there's value to lots of things, and just because you don't understand it, that's the wrong question to ask. A better question is what we're asking: what is the value? What are we learning? Why is this cool?
Nick, do you have something you wanted to add?
I was just thinking of also like more direct benefits, not even fringe stuff. It's just like, I use GPS every day and all sorts of fun things like that. And at this point, well, who knows? Maybe, well, not that I'm a big fan of it, but it seems like satellite internet might be a thing, whether we like it or not. So.
Yeah, and I mean, I would also just like take this back to Star Trek and say that not only like legitimate space travel, but the idea of space travel, the science fiction around space travel has been such a huge inspiration to so many people. I think it has inspired so many young people to get into astronomy, to get into aerospace engineering. And I think it does so much to just get people to think creatively about what's possible. And I'll take it back to Miguel Alcubierre, who joined us as a guest last year, who designed the first possible warp drive because he was a Star Trek fan, and like I think I've said this before, but there's a precedent of science fiction becoming science, and I think that is totally going to continue. And so, because we're pushing the boundaries of how far we can go into space, I think that pushes the boundaries in all parts of what we're going to do as a species, both in space and here on the planet. So I am a strong proponent of both real space travel and imaginary space travel. I mean, I think one of the Wyoming Stargazing former board members and astrophysicists who Nick works with, Brian Keating, has a show called Into the Impossible.
Test.
And I think like that, like for me, captures everything about what we're talking about here. It's like
really great.
Space travel, and even just like human flight. I think has been this idea of like how can we do things that were impossible for the generation before. I think space travel pushes humanity forward. Thank you for sharing that with us, Lieutenant Lahora. Michelle Nichols is your real name. Any other thoughts, ideas about any aspects of her quotation? I know we've talked about the sexism inherent in astrophysics before, and the sciences in general, so we don't have to beat a dead horse. But I did want to point out that that's a big part of what this quotation is about, and it's another reason that I really love Star Trek. I think the deliberateness that Gene Roddenberry had in choosing gender and multi-ethnic crew at a time when that was just not acceptable, and to choose to do that in a futuristic setting that tried to show everybody that this is going to be the norm at some point. I think that's also a really important way that he did so. And so I feel very similarly just about the idea of the cultural nuances of the original Star Trek as I do to this idea being presented here that space travel moves us forward. I think the way that Gene Roddenberry presented the equality in Star Trek, was that like back in the 70s when it first came out, was hugely important.
I agree, and I think it's interesting because, like you said, that was a pretty like very progressive for the time, and you can kind of see like how important that was, but then also you see like progress is progress, and so like now it's like, okay, well maybe they didn't all have to be wearing short skirts, like, but like it was still important, and I think it shows, you know, perfection doesn't have to be, it doesn't have to be perfect, but like if we keep trying, like it's a kind of an iterative process that we just keep getting better. Hopefully that's the goal.
You know, one thing that I really appreciated about, you know, about that whole series is the focus on the mission. And I think just like to your point, I guess to what, you know, Sam and Nora both have been saying, it's really was certainly very powerful. But you know, it's one of those things where it's not about whether it's a man or a woman that's doing it. It's about, you know, the job that they're doing and their effectiveness in achieving the mission. So
yeah, I was walking through the San Francisco airport over the weekend, and there's a really amazing display of the Tuskegee Airmen. And so I was Astro 365, but before we do that, just a mention to all of you viewers out there. We know there's some audio issues, and we are working on it. Hopefully we will get that resolved shortly. So thanks for your patience and sticking with us. Hopefully we can get that figured out before too long. And remember, you can still call in with your questions or chat them on Twitch or YouTube. All right, Astro 365, this day in astrophysics history, and the following couple weeks as well. We don't stick just to today, because there's a lot of cool stuff that happened in the next couple of weeks of February as well. It sounds like maybe nobody can hear me right now, so we'll just have to post the recording of the show later on. So if you can still hear us out there, fantastic. But we'll get the recording posted, and we'll make it happen then. But anyways, so today, on February 15th, a couple incredible things happened. First, a huge meteor crashed through the skies above a small Russian town. And several hundred years earlier than that, on this day, Galileo was born. Galileo was born in 1564 on February 15th. And if you haven't seen the footage of this meteor, and one just interesting thing about all this video footage you're going to see, a lot of this footage comes from dash cams in people's cars. And one of the reasons everybody has a dash cam there is because there happens to be some police corruption. And so everybody has dash cams in order to capture whatever evidence they need. So there's no dirty dealing when they get pulled over for a speeding ticket or anything like that. So fortunately, that's a deal in Russia. Otherwise, we wouldn't have had all this amazing footage of this meteor breaking up. And so, Gavin, if you could cue up that video for us, we will watch it here.
What exploded over Russia? Presented by Science at NASA. When the sun rose over Russia's Ural Mountains on Friday, February 15th, many residents of nearby Chelyabinsk already knew that a space rock was coming. Later that day, an asteroid named 2012 DA14 would pass by Earth only 17,200 miles above Indonesia. There was no danger of a collision, NASA assured the public. Maybe that's why, when the morning sky lit up with a second sun and a shockwave shattered windows in hundreds of buildings around Chelyabinsk, only a few people picking themselves off the ground figured it out right away. This was not a crashing plane or a rocket attack. It was a meteor strike, the most powerful since the Tunguska event of 1908, says Bill Cook of NASA's Meteoroid Environment Office. In a 1 in a million coincidence that still has NASA experts shaking their heads, a small asteroid completely unrelated to 2012 DA14 struck Earth only hours before the publicized event. These are rare events, and it is incredible to see them happening on the same day, says Paul Chodas of NASA's Near-Earth Object Program at JPL. Researchers have since pieced together what happened. The most telling information came from a network of infrasound sensors operated by the Comprehensive Test Ban Treaty Organization. Their purpose is to monitor nuclear explosions. Infrasound is a type of very low-frequency sound wave that only elephants, homing pigeons, and a few other animals can hear. It turns out that meteors entering Earth's atmosphere cause ripples of infrasound to spread through the air of our planet. By analyzing infrasound records, it is possible to learn how long a meteor was in the air, which direction it traveled, and how much energy it unleashed. The Russian meteor's infrasound signal was detected by multiple stations, including one in Alaska more than 6,500 kilometers from Chelyabinsk. Western Ontario professor of physics Peter Brown analyzed the data. The asteroid was about 17 meters in diameter and weighed approximately 10,000 metric tons, he reports. It struck Earth's atmosphere at 40,000 miles per hour and broke apart about 12 to 15 miles above Earth's surface. The energy of the resulting explosion exceeded 470 kilotons of TNT. For comparison, the first atomic bombs produced only 15 to 20 kilotons. Based on the trajectory of the fireball, analysts have also plotted its orbit. It originally came from the asteroid belt, about 2.5 times farther from the Sun than Earth, says Cook. Comparing the orbit of the Russian meteor to that of 2012 DA14, NASA orbit analysts have shown that there is no connection between the two. These are independent objects, Cook says. The fact that they reached Earth on the same day, one just a little closer than the other, appears to be a complete coincidence. Infrasound records confirm that the meteor entered the atmosphere at a shallow angle of about 20 degrees and lasted more than 30 seconds before it exploded. The loud report, which was heard and felt for hundreds of miles, marked the beginning of a scientific scavenger hunt. Thousands of fragments of the meteor are now scattered across the Ural countryside, and a small fraction have already been found. Preliminary reports, mainly communicated through the media, suggest that the asteroid was made mostly of stone with a bit of iron. In other words, a typical asteroid from beyond the orbit of Mars, says Cook. There are millions more just like it. And that is something to think about as the cleanup in Chelyabinsk continues. For more news about things coming out of the blue, visit science.nasa.gov.
All right. Well, we hope you enjoyed that short video about that meteor. And, as was talked about in the meteor or in the video, there are a lot of other chunks of rock out there. And so we'll definitely have a show at some point about near Earth objects and the potential threat they have on Earth, especially with, Don't Look Up being such a popular film right now. Nick, what do you got for us?
I was just thinking, it's one of those things I kind of want to see, but I also don't want to see because it's just a few meters in diameter one way or another. It can be a whole different story there.
Indeed.
I'd be doing some duck and cover drills if I saw that.
Right? We're all trying, so we would know what it was, but I'm not really sure I know, like, I feel like, all right, so I should find a basement, but what's, you're calculating while you're trying to figure out what the sound speed is for the shock wave, then it hits you.
I could at least like put the brakes on my car. They all just keep driving towards the like glowing ball of fire without slowing down. Supposedly, that was what my takeaway from the series.
Yeah.
Well, can at least stop.
Apparently, there were news reports that it was going to happen. Apparently, it was a known event, and so a lot of them expected like a big meteor to like flash up into the sky at some point that morning.
Humans are amazing that they took that information. We're like, okay, just go about my day then. Like,
right?
oh, cool.
I mean, clearly, like not the people in those like office buildings where like the shock wave like broke all that glass. There are videos on YouTube that like just are like compilations of glass breaking in different like warehouses and offices, and it was pretty dramatic, for like 100 miles, and that thing was only 50 feet across, which is pretty small when you think about it, compared to like some of the big rocks that are probably, floating around out there, and some of the biggest asteroids, much larger than that. But anyways, go ahead.
I was saying, I think like you would think that like, oh, right, there'll be an earthquake because it's impacting the ground, but not necessarily think about the fact that like, no, that sort of an explosion also causes a wave in the air, which is what's going to come through. And so I didn't even know that until a few years ago when I had to start learning these things for my job. It's like, oh, that's cool. If they're very big enough, you actually get a huge fireball that can come like evaporate things, which again is not ideal for people anywhere near that, but it's really cool to think about.
Yeah. Yeah, I mean, I would love to see an impact like that from a distance. Well, I just wanted to share that video because I love watching that footage, so I hope you all enjoyed it out there watching the show. Several other really interesting things happened in the history of astronomy in these last 2 weeks of February over the years, and I just want to highlight a couple of them. So, not just one great astronomer being born on February 15th, in 1564, Galileo. Also, Nicholas Copernicus was born in the month of February on February 19th in 1473. And then in 1930, Clyde Tombaugh discovered Pluto. That was on February 18th. On February 20th in 1962, John Glenn became the first American in orbit. In 1977, the first flight of the space shuttle took place on top of Boeing 747. That was on February 26th. In 1968, on February 24th, that was when the now Dame Jocelyn Bell Burnell, then just a graduate student, announced the discovery of the first pulsar star. And then, last but not least, in 1987, supernova 1987A exploded on February 23rd. So I don't know why February is chock full of all these amazing events in the history of astronomy. Being the shortest month, you might think that it would have the fewest events, but not the case at all. Anybody have any tidbits to add to any of these events in astrophysics history?
Well, I think we also got a new one now, right? First light JWST. Or...
Yeah, that's right. If you didn't catch that comment that Nick just made, the James Webb Space Telescope reported first light. Photographed a star. It's still just in the testing phase. We're not doing research yet, but it works, which is pretty sweet. And so, yeah, we still have to wait until June before we get, the first really detailed images. But yeah, it is up and running, which is pretty phenomenal. And so, yeah, add that into the list of great moments in the history of astrophysics. Do you remember what day that was this month, Nick?
I don't know when they released the image. I feel like it was just this last week, though.
Yeah. Sometime
They released it on Friday.
On Friday.
There you go.
Cool.
And that's just the first photons. NASA was hesitant to use the term first light in their press conference.
Yeah.
One
I
of the
know they
reporters
don't, but
was
I'm
like
gonna
really
use it.
pushing them on it. They're like, but would it be accurate to say first light? And the guy was like, well, we don't really want to, like, and they're like, but can I write first light in my article?
Yeah, I mean,
But this is just for NIRCam. So Miri still is not cold enough to have turned on yet. So
right.
we've still got some cool milestones coming.
Yeah.
But
yeah.
one camera on, photons, and for me, I do a lot of in my research figuring out how do you calibrate a telescope once it's up and up and running, and so figuring out how they're doing that with so they looked at one star 18 times, which is the kind of fun part of the image. It's kind of fun to look at, but just they're starting their calibration routine of how to get everything into alignment, and that sort of the whole process they have to go through is very cool. And it's very cool how they've set up the camera to be able to run that calibration sequence. So anyway, I'm still excited about this part, and I think it's a very cool way to do it. But yeah, I get their tentativeness. They really want their first light to be some flashy picture of a nebula or something.
I mean, and I would too. Something to rival, like the pillars of creation from the Hubble Space Telescope or something like that. Not just a little point of light. But maybe this is a good time to point out that when astronomers are collecting data, they're really not interested in all the flashy pictures that all of us amateur astronomers love so much, and that take notice to in our own work in astrophotography. It's really number data that astronomers are interested in who are doing research, but they get pretty pictures that we get to enjoy as well. So we will definitely get some of those from the James Webb Space Telescope in good time. Any other historical moment comments?
Well, I guess the next round of commercial spaceflight opportunities with SpaceX was just announced. You guys might have heard the whole Polaris series. So Polaris Dawn is going to happen later on this year, most likely. It's pretty exciting. So I guess it hasn't actually happened, but the announcement happened for whatever that's worth.
Nice. Yeah, definitely worth noting.
They're gonna do a private spacewalk on that mission, which I think is really exciting. And I was thinking, Danny, of all the spacesuit talk that we were doing, and I guess I don't know much about. I know the spacesuits they wear during launch. Are those the same ones that they would use on a spacewalk? No, they couldn't be the same ones they use on a spacewalk. I guess I don't know what the status of private exterior suits is.
Yeah. So I have something to learn there as well, actually. And I think there's been some talk of SpaceX using the same suits that are used or that are worn in the intravehicular setting. So on IVA, for intravehicular activity or IVA, also to be used for EVA or spacewalks. But that remains to be seen. So I will hopefully find something out very soon, and I can report back to you guys. But regardless, I remember what I had presented to you all at some point, I think last summer, about the spacesuit glove and how pressurization of the glove tends to cause a whole bunch of injuries and other medical issues. That pressurization is going to be something that is constant. So regardless of what suit they use to be able to step out into the vacuum of space, it still needs to be pressurized. So they may well still have those same injuries until the solution is adopted. So
I buy fingernails.
I know, right? At least a couple of them. So
I think I'd pay that price to go on a spacewalk.
I would definitely be willing to give up all of my fingernails. Yeah, and toenails too, if I needed to.
But we can solve the problem.
But I would rather use the gloves that Dr. Danny is designing and not have that happen.
Sounds good.
I'll wait for my first spacewalk until you do that, Danny.
Sounds good. It's a deal.
Sweet. All right. Well, we are. It is about time to transition to our special guest spot. So we're going to take a short break, and then we will be back with Taylor Hutchison. Don't go away. We will see you in just a few moments. See you soon. Welcome back, everybody. We are here with our special guest, Taylor Hutchinson from Texas A&M. Taylor, thanks so much for being here.
Thank you for having me. I'm really excited to be here.
Yeah, it's our pleasure. So we'd like to start all these guest spots off with the same question, which is, what's the one question that you wish everybody would ask you, but nobody actually does?
Yeah, so that was kind of a hard question. So I'm going to give you two answers. Based
sweet. Yeah, great.
Listeners. So just if it were like a more general kind of question, I would love to be asked, do you want to take a nap? Because I remember distinctly in kindergarten being really upset that I had to take naps, and I really wish that could become part of the curriculum again. Could I just like have designated nap times? That would be wonderful. But
That's
then,
awesome.
the science question I would love to be asked is, how much telescope time do you want? Just on which telescope? Just for free, it's yours. So that would be perfect.
I like that. That's fantastic. Your comment about naps actually reminds me of a wonderful time. My first year in grad school, I had this awesome office that I shared with 3 other people, and we had this amazing, enormous couch on one side of the room, and we took turns napping on that couch pretty much every evening, and it was awesome. I actually think there is a picture of me floating around somewhere, actually double fisting it on that couch one evening that actually made it to the department head, and they were not super psyched that that picture got posted. Yeah, we had fun times in that office. But enough about me. Taylor, tell us how you got into the field of astronomy, and what your path was like, and what you're up to now.
Yeah, so I didn't start out as a kid wanting to be an astronomer. True story, but when I was a kid, I really wanted to be an Egyptian mummy. Oddly, like with the full knowledge that means that you're dead and you've been embalmed and like you're wrapped in, I don't know, I think I watched The Mummy at too young of a formative age. And so like for most of my childhood, I just really wanted to be an Egyptian mummy. There's a picture of me in kindergarten, like just really seriously like doing the mummy pose. And then when I got to older ages like middle school and high school, I realized that's not an actual good career goal to have. So I in middle school figured out that I really like math. There are certain parts of math that are incredibly exciting to me, and so I thought that meant I needed to be a mathematician. And then when I got to high school, I had this really amazing physicist as one of my teachers. She had a PhD in nuclear physics, I think, Dr. J. And she showed me how awesome physics is, and the fact that all the things I liked in math are used in physics, which was perfect. And so then I went to college for physics. And while I was at this small liberal arts university where fixed department had like 3 faculty, I happened to meet one of them who was an astrophysicist. And he's like, hey, you want to work at the observatory? And kind of similar to the question I always want to be asked, do you want telescope time? And so he introduced me to astronomy, and that's kind of, I haven't looked back since, but it's funny because a lot of my colleagues have been wanting to do this since they were kids. And it was a recent decision to go into astronomy, all things considered.
Wow, that's an amazing story. So I've got a few questions for you, if you don't mind.
Oh, sure.
So the first one, did you ever dress up as an Egyptian mummy for Halloween? Was that your thing for a while?
That would make sense. No, actually, I think it was mostly I just channeled it. Like in those pictures as a kid, like a tiny little blonde girl doing the mummy pose. Like I would channel it instead. So I never really dressed up as a mummy, I don't think.
Okay. And then secondly, I'm intrigued about the areas of math that were so intriguing to you.
Yeah, so starting out in middle school, right? It's not as complicated as it gets in college, but I loved the problem-solving aspects of math. The parts I don't like of math, even still, as a scientist, are the proofs and trying to write the proofs or having that little trick that answers the question. And if you don't memorize that trick, then you don't get the question right. I don't like those, but I do like the problem-solving aspects, and especially calculus. When I got to college, calculus is so cool. Like the fact that the volume of a sphere, 4/3 pi r cubed, if you take the derivative of it, it becomes 4 pi r squared, and that's the surface area of the sphere. And so like that was just kind of blew my mind the first time I made that connection. So those are the things I really like about it. And, you know, all those fun parts are used in the problem solving that we use when we do astronomy. So, you know, it's all kind of connected that way.
That is super cool. And the other question that I had was, what small liberal arts college did you go to?
Yeah, so I went to Southwestern University, which is in Georgetown, Texas, a little north of Austin. It was actually great though. I know that in grad school, especially when you're doing a science, it's a little weird to come from a place from your undergrad that isn't like an R1 institution or a very science focused place. But I do think that being from a liberal arts university was a big advantage in my case, because as a liberal arts student, you're required to take humanities courses, you know, so tons of writing and history and things like that. And it definitely has only helped me as a scientist because we write so much, be it, you know, papers or telescope proposals, grant funding. There's so much persuasive and regular communication and writing you have to do. And so I love the fact that I came from a liberal arts university.
That's awesome. I also went to a small liberal arts university college for undergrad and had a very similar experience as you just described. I wrote a lot and read
so much.
Yeah. And I agree with you. I think that's been really beneficial. And yeah, like you, I also got really lucky and met a new astrophysicist who had just been hired, and that's how I got into astronomy. Yeah. So tell us about the kind of research that you do now in astronomy, Taylor.
Sure. So kind of like the title of this event is suggesting, I work with some of the most, if not the most distant galaxies we've ever discovered so far. So what this means is I'm looking into a time in the early cosmic universe where, you know, the first stars and galaxies are forming. And so this is incredibly far back in time. You know, if we assume that the universe is about 14 billion years old, approximately, don't talk to cosmologists and say that number. But if we assume 14 billion years old, then the galaxies I look for, the light has traveled over 13 billion years to reach us. And so, you know, they've existed when the universe is less than 1 billion years old. And so what I like to say is because it took so long for the light to get to us, what we're really seeing when we look at these really distant galaxies is kind of like the baby pictures of these galaxies, you know. So I'm looking at the infant images, but if you were to like magically transport there, like with a wizard or something, those galaxies might not even exist anymore, or they would look incredibly different. And that's just kind of a really fun little puzzle in your brain that I've always struggled to kind of wrap my mind around, and the way that cosmic time and distance are very confusing when you talk about space-time. But yeah, those are the distant galaxies to look for. And so it's very challenging. It requires using 10-meter wide telescopes in Hawaii, and very soon, knock on wood, the JWST in space, 1 million miles away. So yeah, it's really exciting.
And so what, how did you get into that area of study? What excites you about it? And what specific studies are you working on now?
So when I came into graduate school, an undergrad, the professor I worked with, we were mostly working on supermassive black holes in the centers of nearby galaxies. Like most galaxies, honestly, have some kind of massive black hole in their center, and it can actively be accreting material or not. But we were specifically focusing on like these active supermassive black holes in the centers of very close by galaxies, the ones that have, you know, NGC as part of their identifiers. You know, they're that close, like redshift 0, essentially. And so going into grad school, I thought that's what I wanted to do. And then I met my current advisor, Professor Casey Papovich, and he kind of works at a large range of science and redshifts, but he had just gotten telescope time on the 10-meter telescope Keck Observatory in Hawaii, and was like, hey, you want to come with me and look at these really awesome, incredibly distant galaxies? And I was like, yes. And so that's kind of how it started. So during that observing run, just for reference, these telescopes are so amazing and everyone wants to use them because they're, 30 feet wide, that it's, if you were to buy telescope time, it would probably be like $100,000 a night. Obviously we don't buy telescope time, right? We all propose for this time, but it's that highly coveted of a telescope. And so the fact that you can observe on it is awesome. And through that one night of observing, we got a detection of an emission line, or just, very specific kinds of light from a galaxy at redshift 7.5, which is about 800 million years after Big Bang. And so about 12.8 billion years ago. And it was just like crazy. and incredibly exciting. And that's just from that moment I was hooked. And the things you can kind of uncover when you start to get this kind of spectroscopy of these really distant galaxies are really fun. Like, it's very hard to get these detections, but the minute that you start to detect the light from these galaxies, you can start to pick apart, what's the ionizing source inside these galaxies? Is it, this really massive accreting supermassive black hole emitting tons of ionizing radiation? Or is it really massive stars, kind of reminiscent of the first stars that would have formed? We're expecting them to be very large, like 30 to 300 times the size of our sun. And so you can start to, taking the observations that you have, including tons of imaging from the Hubble Space Telescope, in addition to that, and then comparing to tons of modeling, you can kind of pick apart what's going on in these sources. And it's the puzzle, like piecing together the puzzle pieces, like I said before, it's very much part of it, because this is what the kind of science we can do with just scant detections. But the kind of science we're about to be able to do with the JWST and all of the really awesome data with much higher sensitivity and quality that's about to come in through these redshifts. Yeah, it's just really exciting. So my subfield specifically has been very slow growth at this, the past 10 years is very new, but it's about to explode and starting June when we start getting that data in.
That's awesome. Yeah, I was looking at your bio on the Texas A&M website, and I saw that you've been using infrared instruments to do your research, and I thought, wow, you are psyched about the JWST.
So much. I definitely get told by family members to shut up because I talk about it so much. Yes, so I definitely work in near infrared, and that's the crazy part, right? Because of redshift, these redshifts are 6 and greater, and so just to translate that, the ultraviolet light from these galaxies is in the infrared by the time it gets to us. So the first light you could possibly see from these galaxies is in the infrared. So yeah, that telescope is going to completely change the kind of science I can do. We'll actually learn way more about these galaxies than we've ever been able to before. So
do you have any hunches on questions that it might answer early on in its use about these galaxies?
Yeah, there's a few, I feel like, that are really obvious, like straightforward things, like hopefully, at least, right? The most distant galaxies. We were currently pushing the limits. We have one galaxy that I think has a detection at redshift 11, which is amazing. Like, that's crazy. But after that, it's down to like redshift 8. And so it's really hard to get detections of galaxies at these redshifts. So the first thing I'm expecting is that we'll be able to very easily get detections of galaxies at redshifts 11 and greater. So truly less than 500 million years after the Big Bang, like some of the first galaxies, if not the next generation after the first galaxies. And so I think that's going to be, fingers crossed, that's going to be just kind of a given. Like, we're going to get that with this telescope. But one of the things I'm really excited about is, aside from the things that we're expecting, because NASA has 4 science cases, with my science being one of them, but the weird stuff, like, I feel like there's a lot of things we don't understand. And the infrared's really interesting and challenging for tons of redshifts. And so I'm really excited for the weird things we're going to find, especially the redshifts I care about, because we have this expectation of, we have these really young galaxies, incredibly massive stars, lots of really powerful ionizing radiation pouring into the surrounding medium around these galaxies. But what if there's other stuff out there too? We just haven't been able to see it because we have this selection bias in the way that we're looking for stuff. With this telescope, we might be able to find that. And so the weird stuff is like the thing I'm most excited about, the stuff you can't really anticipate. So
I love that. Very, very cool. Co-stars, any other questions that you have for Taylor?
I have one.
Sure.
So Taylor, after you graduate from this PhD program, what's next?
That's actually a really well-timed question. I just accepted a NASA postdoctoral program fellowship.
Congratulations.
Yeah,
Congrats.
so
that's awesome.
Going to be doing this exact science full-time, all JWST, for my postdoc career for like the next 3 years. So yeah, thank you. A very well-timed question.
Perfect. Congratulations. That's awesome.
Thank you.
Are you sticking around at Texas A&M for that?
No, actually, this will be the first time I'm moving out of Texas in my life. So I'm going to Goddard Space Flight Center over in Maryland. So very close to DC. It'll be fun.
Very cool. For the benefit of our viewers, who might not know what redshifts refer to. Would you mind taking a moment to just explain that a little bit to folks?
Sure. The way I like to explain it is, so when you're talking about distance, when you get to space scales, you suddenly have to fold into the concept of time, right? Because, for example, the sun is so far away from us that it takes about 8 minutes for the light to reach us. So if you had like a magical wizard, I keep bringing up wizards. Sorry, I was raised with like Lord of the Rings and Star Trek. If you had a magical wizard just like remove the sun, it theoretically could take 8 minutes for us to tell, because it takes the light that time to travel. We would know faster than that because we have space telescopes, but that's kind of the concept. So even the sun in our own solar system is far enough away that there's a light delay, and because the distance is so vast. And so the concept of redshift really folds this whole space-time concept. And so the further out you're looking in space, the further back in time you're essentially looking, because it takes light much longer to travel to us. And so I like to say that when you're looking out into space, you're looking back into time. And so astronomers are kind of also archaeologists, but in space. And so there's this really beautiful symmetry to the kind of archaeology work we do on the Earth versus what we do in space. And so when we talk about redshift, all that really is implying is how far away is that source from us? And so you can kind of translate that to, how long is it taking that light to reach us? And so redshift 6, just as a base mark or a benchmark, is, about 1 billion years after the Big Bang. And redshift 0, where we are right now, is about 14 billion years after the Big Bang. So you kind of can just like walk back in time using the Z number, which is redshift, and which is much easier to say than, however many millions of years or billions of years, or, centimeters, which is, oh, why are we using centimeters when we talk about these distances? But astronomy units. So that's kind of the reason why we use the word redshift.
So why, why does the color of the light correlate with its distance then? Because redshift refers to the color, right?
True. Yes. So it's all kind of connected. So the fact that it's taking this light so long to get to us, it is stretching out the light on its path. And so this ultraviolet light, that is a really good point. Yeah, the ultraviolet light emitted from these really distant galaxies, like the ones I look at, as that light travels to us, it's getting stretched in space-time. And so by the time it reaches us, these wavelengths are longer, or redder wavelengths. And so we see them in the infrared. And so a really good Earth-based example of this, if that concept's a little weird for people watching, is Earth-friendly examples like the ambulance. So if you have an ambulance or a fire truck, with its piercing siren and it's stationary, then everyone around the fire truck's going to hear that piercing sound at the same pitch, because it's not moving. But if the fire truck starts to zoom off to go and save someone from a fire, then people in front of the fire truck on the sidewalk, hopefully, will hear a higher pitch sound because the sound waves are being compressed as it moves towards them. And then once the fire truck passes, you'll hear a lower pitch sound because the fire truck is moving away. So the sound waves are being stretched out. And so in a very similar way with redshift and the way that the light works, when I'm saying it's being stretched by space-time, what I mean is because of the expansion of the universe, we have these galaxies moving away from us. And so based on the distance and how they're moving away from us, the light waves are being stretched out as it travels. And that's why we'll see this ultraviolet light in the infrared once it hits our telescopes. Did that make sense?
Totally.
Definitely.
That was great.
Thanks.
Yeah, thanks so much.
So I just want to get this straight though. So you're talking about basically big picture, you're looking for cosmic mummies with the whole archaeology reference.
Oh,
nice.
Okay, cool.
Jenny. Nice.
Perfect. It all comes full circle, right?
Oh, beautiful. That makes me so happy. Oh, I'm going to write that in my dissertation.
Happy to help.
Oh, that was clutch. Very nice. Any other questions or Nick, go ahead.
Yeah, no, I got a quick one about what it's like to be a modern day observer. It sounds like you got to go to Hawaii, which that sounds like a cool deal. I assume most of it's remote these days, but what is the kind of standard thing? Do they bring you out there occasionally, or is that just for the first time training and then it's all remote, or they try and maintain some mix?
That's a great question. Yeah, so being an observational astronomer, I travel a ton, or pre-pandemic, I traveled a ton. And so I was going to telescopes probably 3 times a year. And because of my science and I need the biggest telescopes possible, I was going to Hawaii specifically at least twice a year to use those telescopes. And the way that I apply for time is I apply through NASA's allotment of time on those kinds of telescopes. And so what that means is it's incredibly competitive, first of all. But then you get money from NASA essentially to do your science. And so using that money, you can, you know, buy a plane ticket and fly out there and observe. And usually they prefer that you do this in person. Obviously, in the pandemic times, it's been different. So I have remotely observed for the past 2 years everywhere. But yeah, so I you know, I've been to Chile and Hawaii and Arizona and, you know, the McDonald Observatory in West Texas, which is beautiful. So it's been really nice being that kind of astronomer that I can actually go and do those things, because I definitely think that observatories are kind of my church. Like when you're there, it's like this Zen feeling, and it's like truly peaceful. And like at night, and you just look up at the cosmos, and it's just you and the galaxies you're looking at. Yeah, it's a really wonderful experience. So I can't wait to be able to do that in person again, because it just doesn't feel the same when you're remotely doing it. So as often as I can, I would like to observe.
Cool. Yeah. It's going to be a little tougher with JWST though.
Yes, it's true. I'm going to help out with anyone else's time on telescopes just so I can get that fix.
You know, this just occurred to me. The fact that the JWST is 1,000,000 miles away, and how like that phrase gets used so often. Oh, it's 1,000,000 miles away. Now we actually have an awesome telescope that's really 1,000,000 miles away. And so I feel like that saying just has so much more meaning for me now.
Yeah, no, it's crazy. I definitely wish we could go out there and use it. That'd be really cool. But there are the future generations of these massive space telescopes. I know people are talking about making them where they're commissionable, like so where they can like bring them back into orbit around the Earth and then put them back out there. So that'd be really cool. And not likely with this one though. They didn't make it that way.
I have to wonder whether like Elon Musk or Bezos, they're scheming of like, how could we possibly like make something to get out there at the, you know, the end of the lifetime of this instrument in 20 years or 30 years. Like they must be thinking about that. I'd be shocked if they're not.
It's definitely, that would be the no offense to anyone who likes them, but that would definitely be the perfect ego project.
Exactly, right? Totally. Yeah. Yep. I mean, that's why I think it's the two of them thinking about it.
I was gonna say your point earlier about math, I thought was really interesting, because I too really love math, but I love, you know, calculus. I love like higher level math, but like that's really not the same as like studying math at like higher levels. It gets very different very quickly. And I think that's also similarly, you see that actually a lot with astronomy, that people like studying astronomy and they like doing like stargazing, but like very quickly don't want to like get involved in the like higher levels of it. And that's kind of how I feel about math.
Yeah, no, 100%. I completely agree. That's why I like that, you know, astronomy and physics are kind of the applications of math in a way.
Yes. There's a really excellent XKCD that's like, you know, chemistry. It's like, oh, like physicists are just looking down on chemists because it's like, oh, that's just like applied physics or whatever. And it's like this whole chain of sciences. And then at like the very far end, it's like mathematicians, and they're just looking at everybody going, ha. They really are at the top of the abstract like thought pyramid.
Yeah, but they're also truly used by everyone. They are not the original science, but it kind of feels like it sometimes.
I like to say it's the language of science.
Oh, that's a great way to say it.
I was just going to say, that's what I think of it as too. Yeah. It's how you're expressing all of your thoughts, is just through math instead of words.
That's beautiful.
Yeah. How do we all feel about statistics?
Yeah. That's how I feel.
Slightly less poetic. I like statistics. I'm just bad at it. I'm so bad at it. It makes my head hurt. I'm not a good Bayesian.
It's a less attractive dialect.
Right? Yeah, exactly.
I think statistics, you know, if you're thinking about like fonts, it would be like windings. You remember that, like bizarre like conglomeration of different characters you got on like Microsoft Word.
And you're like, does that say what I want it to say?
Yeah. I don't know, like who dreamed that one up, but yeah, that's not a language, but a font. Close enough, right?
That's a good description.
Well, we're just about out of time, but Taylor, if you don't mind, I have one more personal question for you. I've noticed your tattoos, and they're super cool. I was wondering if you wouldn't mind telling us a little bit about your tattoos.
Yeah, that's actually one of my favorite questions. So thank you.
Oh, sweet.
Yeah, so in addition to wanting to be an Egyptian mummy, I've always been fascinated by like marine biology. And I loved the idea of, working with marine animals. And, in my mind, it was very, romanticized where we're scuba diving every day to go look at the dolphins. But I do love the ocean, and I love the fact that it's a kind of really beautiful symmetry between the ocean and space, because, we know very little still about our own oceans and seas. There's so much left to be discovered, and the same way with the space, there's just so much left to be discovered. And so this is actually an octopus. I don't know if y'all can see it. There you go. That's his face. Because I love them. I do think like if humans, again, let's bring back that magic wizard. If the wizard made humans disappear, I feel like octopi could become a dominant species because they're so smart. And then this is another marine biology tattoo that my sister designed. So that's kind of my favorite thing to do, is cover myself with more marine biology tattoos and then do astronomy as my career. So
very cool. That's awesome. I take it you saw My Octopus Teacher.
Yes, I did. I thought you said t-shirt at first. But no, that was a really cute film.
Yeah. For those of you out there who haven't seen that documentary on Netflix, My Octopus Teacher, really worth watching. So cool, and definitely speaks to the intelligence of octopi that Taylor was just mentioning. Yeah, it's really touching.
They also make great tattoos. I'm all in support of every scientist ever getting a tattoo. I think they're fantastic. So if you need encouragement, just come talk to me.
I don't have any tattoos. There's one that I've been thinking about for years and years and years, and I just haven't done it. There is a 16th century wood carving that's attributed to a guy by the name of Camille Flammarion. And I bet you all have seen this print. It's all over the internet. So it's a picture of a scene with like a symbol of like a tree of knowledge, and there's a monk kneeling down by the tree, and he's staring off into the distance, and his arm is outstretched, and his arm is piercing through like the Aristotelian spheres of the early concept of the universe. And like the foreground is kind of like the confluence of like something like Tigris, Euphrates rivers. And so it's just this symbol of knowledge and exploration and the search for truth. And I came across it in high school when I was writing one of my college essays, and figured out like where this print was from. I actually had to write an essay about it. And so it's super cool. But to actually see the detail on this, it would have to be like across my back. And like, it would have to be like my full back.
Is that a problem?
No, it's not a problem. I think it's just taken me maybe a little bit longer to take that dive for my first tattoo than maybe like getting a little like, galaxy on my arm might have.
You could start with a constellation and then, build up from there.
Yeah. That might be a little bit easier than just like, but I'm the kind of guy who kind of just like goes big or go home. So I would probably start with something like that. I mean, find some tattoo artist to commission that for me on my back.
That'd be amazing.
I'll have that picture up for the next Cosmo show and show y'all out there. I'm curious about the rest of the co-stars.
Yeah, what would y'all get?
Yeah, what do y'all have? What would you get if you don't have one?
I do not have any tattoos. Not for lack of I'm not against tattoos. I'm just incredibly indecisive.
Oh, and that's fair.
That feels like a bad quality to bring to like permanently putting things on my body, especially because I was in the Navy, so like everybody I knew had tattoos. So I was like the weird one for not having one. But the one that I've been like noodling on for a long time is just like a little, vertical line drawing of the solar system. So it's kind of cliche, but I think they're cute. So
no, it doesn't matter if it's cliche. That's a perfect. That's
so cute. Yeah, I like that. Nick, Danny, Lauren, come on.
Yeah, I could chime in. I almost got one at one point in Thailand, but didn't quite. It was a complicated series of events. Anyway, and haven't I haven't got back to that yet. But there's a few I had in mind for designs I've drawn, but again, never really had the push or the motivation just yet. With some vague space theme to those, but more abstract, I'd say.
Are you an artist, Nick?
Not let's see here. I'd say I'm very creative and I draw and I have drawn, but it's not something I do a lot of. It's a creative outlet.
Well, that's so cool.
Yeah, I think that counts also.
So there you go. I'll do that when Sam does it.
All right. Well, maybe you can find a tattoo artist for me, Nick.
There we go.
I'll find one for you.
It's a trip out to San Diego, Sam.
Hey, not too far away now. It's like a few hours.
There you go.
I will say
I don't have any tattoos. Oh, sorry. Go ahead.
Sure.
I don't have any tattoos. I think they're fantastic. The concept of like expression through art on your body is wonderful. But I haven't personally gotten any. If anything, I probably would get one at some point, maybe with a constellation. I actually kind of love that idea, but it would be a long time from now, I think. So
I love that concept of a constellation as the gateway tattoo.
Yeah, I mean, right? Why not? I will say it's actually really fun. It's a great conversation starter with children, especially when you're doing outreach and stuff. So for a little bit, I was one of the subject matter experts, really just means free outreach person for NASA and JWST. And it was so great to go and talk about the Space Telescope and then have these little children come up afterward and be like, oh, maybe I could do science too. And these are so pretty. Very cute.
That's awesome. Lauren, tattoos?
No, I think the same as everyone here. I think they're cool. I could see myself wanting one, but just having to decide, like, yes, this is the thing I want to look at forever is daunting in the moment. I have a feeling it'll just be that thing where I've decided, like, okay, I'm going to go do it. It'll go from like 0 to 60 really fast, but I just haven't reached that point yet.
Well, maybe, when the Cosmos show hits the big time and we make our first million, then we can all get a Cosmos show tattoo.
Get a group tattoo.
Right.
Yeah, what do y'all think about that?
Also, the other thing is I'm a wuss, so there's that.
Fine, you'll be fine, Nora.
I would do like the tiniest
small.
tattoo.
Yeah.
Small.
I mean, the nice thing is like the Cosmos show logo is a vector, so we can make it as big or as small as you want. All right, we're definitely out of time now. Taylor, any last thoughts, ideas, inspirations that you would like to leave us with, or any of the listeners with?
Yeah, well, I just want to say I love that the quote for this show was Nichelle Nichols, because Star Trek is like one of my coping mechanisms, and definitely through like undergrad and grad school. So like when I'm specifically doing astronomy, I would just replay like the original and Next Gen and DS9 and all of these, and it has a very special place in my heart. Ignore the Star Wars right there. Star Trek thing I care about.
I noticed that, yeah.
But so I love that it was really nice that this is on the same show. But one quote that I do really like that I heard recently has kind of resonated with me since is, if you're the smartest person in the room, you're in the wrong room. So I would want to pass that on. That's one of my favorite quotes right now.
Nice. Cool. I really love that. I think that ties into the quote that we had for tonight's show as well. I mean, pushing the envelope on what's possible and putting yourself out there. Taylor, thank you so much for joining us this evening. It has been a pleasure chatting with you. Really appreciate your time. We've got a thank you gift for you for your time, and Maggie will reach out to you to make that happen. Thank you again so much for being here. Thanks to all of the co-stars for being here and making this show as cool as it is. I love working with all of you. Thanks to the folks behind the scenes, Maggie, our operations director, and Gavin, our stream master, everybody else who makes the Cosmos show possible, the Wyoming Stargazing Board of Directors, all of our donors, and all of you out there watching the show. Thanks for bearing with us tonight with the audio difficulties. It sounds like we got that figured out about halfway through, so thanks for bearing with us. And we'll look forward to seeing y'all next time in 2 weeks for the upcoming Cosmos show. Until then, be well and don't forget to look up. We'll see you then. Bye.